Welcome back to Orlando Math Learning Academy. And I know recently I've been very busy and it's very hard for me to post one video a week. However, I'm trying to do so. But who knows, in the next 4 or 5 months I could be busier and there's no way I can post a video anymore. Maybe I posted like one video every 2 weeks, and however, again, I try to do one per week anyway, but for some reason I couldn't do. Just don't blame me, okay? So I remember the last time in the last video we talked about quadratic equation. We learned how to solve quadratic equation using the 3 method, and we also started the second section of chapter 4. It's about quadratic function, and we know the standard form of quadratic function is fx equal to ax squared plus bx plus c, and the graph of quadratic, the basic quadratic function, is fx equal ax squared. If a is greater than 0, we know it's going to be open up and we had a minimum. If a is less than 0, we know it's going to be open down and we have maximum. And we also have the axis of symmetry that goes through the vertex of the parabola. Okay, so in this video we're gonna investigate it further into a quadratic function. The next thing I want to talk about quadratic function is the point maximum, the point maximum and the minimum here. Okay, we want to talk about the coordinate of this point. Okay. And in order to get the coordinate of this maximum or minimum point, we use something called vertex formula. Okay, vertex formula of quadratic equation, of quadratic function. Basically, what we do is we try to find the coordinate of the vertex point, and because it's a coordinate, so we have to find x component and y component. And the vertex formula is used to find the x component of the vertex. So the x component of the vertex I denoted as x v equal negative b over 2a. So this is the vertex formula right here. Negative b over 2a. B is the coefficient of the middle term of quadratic function, and a is the leading coefficient of the quadratic function. And as long as we have the x component of quadratic function of a vertex point, then we can find a y component of the vertex point easily by just plug into the function. It means we can see the xv here, the x component of the vertex point as the input, and in order to find the output we just plug into the function. So yv, this is the output, equal to f of negative b over 2a. When I write f of negative b over 2a, I mean you plug negative b over 2a into fx equal to ax squared plus bx plus c. Okay, so this is xv and this is yv. Then you have the coordinate of the vertex point. I'm sorry. Okay. All right, and another thing I also want to and because this is the x component of the vertex form, and you know the axis of symmetry is going through the vertex point, so the axis of symmetry also in the form of negative b over 2a, in the form of xv. Okay, so this is also the equation. This is also the equation of axis of symmetry. And we also know this. The axis of symmetry is a vertical line, because every vertical line you see it will start with x equals something. For example, x equals 2, then it goes point at 2, and the vertical the perpendicular to the x-axis. Okay, right here. That's why we have the axis of symmetry is vertical line like this, right? And it goes through the vertex point right here. Okay, so we're gonna have x equal to negative b over 2a. Let's take a look at this one example so that you understand better. So let's consider the function fx equal to x squared plus 4x minus 12, and I want to find the vertex point, the coordinate of the vertex point. Okay, it means we need to find xv. So now can I calculate xv equal negative b over 2a. Negative b over here is 4, so negative b negative 4. 2a is invisible 1 right here, so I have a negative 4 over 2 give you negative 2, right? And after I got the xv, I just calculate the yv equal to f of xv, and xv equal to f of negative 2. Remember when we learn how to do something like this, the input and output, evaluate the output given the input. Remember, this is a part of intermediate algebra. So we plug f negative 2 into the equation. Negative 2 squared plus 4 negative 2 minus 12 give you 4, minus 8 negative 12 give you negative 4, negative 12 give you negative 16. Then we have a coordinate of the vertex v. I just named the vertex is v, is negative 2, negative 16. Okay, so this will be very simple. Okay, and the reason why we have to find, and I'm sorry, after we got the coordinate of the vertex point, we can find the axis of symmetry equation of axis of symmetry. It will be x equal negative 2. You don't put xv anymore, okay, because xv is the component of the vertex point. However, the axis of symmetry, the equation is x equal to negative 2. The reason we want to find the vertex and we want to define the axis of symmetry because it helps us to graph the quadratic function better. Based on the axis of symmetry, we can find more points based on, for example, I can mirror one point about the axis of symmetry in order to get another point. That's what the axis of symmetry for. Okay, let me see. I can graph one of the quadratic functions so that you can understand the graph also. Okay, let me graph this anyway. Let me see. I can graph it because this is negative 12, so the negative 12, so I don't want, because it's too big. So let's pick something with a smaller number. Let me see. Well, I guess I'll just go ahead and use it and using this for graphing. I cannot scale it because it's negative 12, so I just mark negative 12. Okay, so the vertex, just go ahead and define the vertex. The vertex has a coordinate is negative 2 and negative 6, negative 2 here, and negative 16 should be over here. So this is the negative 2. This is the axis of symmetry. This is a vertex right here. Okay, and xv is the y-intercept is negative 12. because f of 0 equal to 0 plus 4 times 0 minus 12 give you negative 12. In order to find the y-intercept, we replace x equals 0. Remember that the part is 0 learned in intermediate algebra also. So it's negative 12 right here. Okay, so your function, the graph of your function will be something like this. So because you have negative 12 here, one point you define one point, so you can mirror this point over the axis of symmetry. That's what I mean. This is the purpose of axis of symmetry, in order to mirror one point. Okay, to get another point. So you get another point here. It's easier for you to graph. There you go. Okay. This is not scale, so it's just relatively the graph is just relatively okay. I mean, it's not quite perfect, but it's okay, you know, as long as you understand it. Okay. So after we understand the concept of vertex and we learn the coordinate of the vertex, we want to talk about another form of quadratic function. It's called vertex form of quadratic function. Okay. So what does it mean by vertex form of quadratic function? Try using this. Okay. We learn so far. We learned the standard form of a quadratic function, which is f(x) equal to ax squared plus bx plus c. Okay, the vertex form of quadratic function is as follow. Fx equal to ax minus h squared plus k. So the leading coefficient will be unchanged. It means that the value of a over here, the a in the leading coefficient of the standard form will be the same. The h and k basically is the coordinate of the vertex. Okay, last time we used xv and yv. So basically xv is h and yv equal k. So they just use different notation. H and k is just for make the vertex form of quadratic function look better. You know what I mean? Instead of put over here x minus xv and plus yv, they use h and k. Okay. And again, if a is greater than 0, we have the open up quadratic parabola. If a less than 0, we have open down parabola. And between two form quadratic function, we can convert back and forth. What I mean is that I can convert the vertex form to a standard form, or I can convert the standard form to vertex form. In order to convert the vertex form to standard form, I just go ahead and expand this. Okay, I just go ahead and expand this. For example, I have the vertex form of the function fx equal let me see, fx equal what? Try to find one of the example here. Phi equal x minus 1 square plus 7. Okay, so your vertex will be, the coordinate will be 1, 7, right? Because h over here and k over here. Okay, and as I say, I can convert this vertex form to standard form easily by expand by expanding the perfect square right here. So what I mean is that I just go ahead and expand this, give you x squared minus 2x plus 1 plus 7, give you, then I distribute it and I combine line term, and it give you, see that give you the standard form easily. And the way we convert the standard form to the vertex form is to use the completing the square method, and that is also very easy because you already learned how to complete the square in the last section, I believe so, in the last video. So I can convert it back easily. The first step to convert it back to complete the square is we have to bring the leading coefficient to 1 instead of 5. It means that we have to factor number 5 out. Okay. Then again, this is the middle term. I just go ahead and divide it by 2, right? Then square it. But okay, give you 25. However, we have to subtract by 25. Okay. Then I'm going to distribute it. 75 plus 12, and I'm going to have the perfect square right here, x minus oh, hold on, yeah, x minus I think I did something wrong, right? X minus 5 square. Oh, I think I did something wrong. Oh yes, right here I factor number 5, but I did not. I still keep the number 10. So let me redo the whole thing. I'm sorry. Let me redo the whole thing. So I factor number 5 out. So over here I have only 2. I'm sorry. Then I take this divided by 2 and you square it by 1 to give you plus 1. However, we have to subtract by 1. Then I distribute it. And this is the perfect square right here, and give you 7. See, it is the same. So the step I want you to be careful is right here. After you divide, you squared it, you got a new value is 1, but you also have to subtract it by 1 because we just cannot just put number 1 here. Okay, this step is very easy for you to commit mistake right here. So be careful when you divide it, you square it, and you add to it, but you also have to subtract whatever you have here. You have to subtract by the same number. Okay. Then after that you're gonna distribute it, but I'm gonna just distribute one by one. I distribute the first 3 terms at once. Okay, then the last term. Okay, it means that I just go ahead and put 5 times the first 3 terms inside parentheses, then 5 times -1 plus 12. Then afterward you have a perfect square right here, and you can combine like term. Okay. So that is the method to convert back and forth between standard form and vertex form. In the test, I don't think I'm gonna let you to. I don't think I give you assessment on that. However, it's good to know though. This is just algebra, and you should practice to be better on this. Okay. And given a vertex form of a quadratic function, we can graph it easily. Okay, because the vertex form, it gives us the vertex coordinate right away. As long as you got a vertex coordinate, then you can get the vertex point, the coordinate of the vertex point, and the axis of symmetry. So in this case, the vertex is 1, 7. So let's this is divided 4 1 2 3 4 5 6 7 8, so 7 here, 1 right here, so this is vertex. Okay, and I can calculate the y-intercept also. It is 12, 7, 8, 9, 10, 11, 12, so it's right here, and the axis of symmetry is go through the vertex point. So because this, I can mirror about axis of symmetry, so I have another point here. So as long as I have 3 points, I can connect that in order to get the parabola, and you see that this is very corresponding to the leading coefficient A over here. It's 5 because it's positive, so it should be opening up. Okay. Good. All right. And sometimes we also, not sometimes, as long as you had a vertex form, we also use we can also use transformation based on the original form is in order to get the graph. But you know what, I can do both of them, but in this example I just go ahead and grab it using the vertex coordinate and the axis of symmetry. Okay. Alright, let's do a few more examples on quadratic function. Some application. Let me see, I can pick one of them in the books. In section 4.2, they also talk about average rate of change of quadratic function. However, the average rate of change of quadratic function or any function, we use the same formula, you know. So if you have 2 points, you can plug into the average rate of change formula, which we already learned in previous chapter. I don't think I'm gonna just repeat it anymore. So I just go ahead and just try to find some application on quadratic function so that you can see how this concept apply in a real world. Okay, let me see. Well, in the homework part of section, I see that there's a lot of problem of finding average rate of change. That's very easy. Okay, we're not doing that. We're not doing that. Okay. Let me see. Say one of the very interesting application problem here, but I don't know. Is 80 that is better? Or oh, I think I forgot to mention something. When the graph is open up, for example in this graph, right? If A0 or for the example is this graph, we call it concave up, and it open up, we call it concave down. Okay, this is more mathematical term we use a lot though, and we use open up and open down. It's not really a mathematical term. Okay. Okay, so for a real world application, I think I'm gonna do this problem right here. Okay, problem 47 right here. Let's read the problem together. Stephen is an exchange student from Germany who is working at local theme park drawing caricature of the tourists visiting the park. He provides all of his material but pays a booth rental fee. The cost of operating his caricature art business is given by Cx equal to this, where x is number of caricature draw. So x represents the number of caricature. Okay, draws. Okay. and x greater than 0, of course must be greater than 0. We don't have negative curvature here. I don't know if I pronounce it right. Curvature? I haven't seen this word for a pretty long time when I was in the humanity class. Okay, but anyway, we're doing mathematics, so it's not a big problem. Okay, so we want to find the vertex cost function. They give you the cost function already. You want to find the cost function, the vertex, and interpret using the complete sentence. All right, so they give you the cost function is cx equal 0.25 x minus 10 squared plus 30. So it's this in dollars because it's cost. So x represent the number of curvature here. So, and you know this is a, and a is positive. It means the graph is kind of like this. I don't know exactly, but I know it's gonna open up. Okay. And because it opened up, we know the vertex will be the minimum point. So this is the minimum point. Okay, and they want us to find a vertex, so the vertex will be 10 and 30 according to this vertex form of the quadratic function. And what does it mean by 10 and 30? It means that in order to get the lower cost, let me see how I should interpret this. This is the cost function. So in order to get the lower cost, he needs to hold on, let me see. In order to get the lower cost, the minimum point is the lowest point, so it should be the lowest cost. Yep. In order to get the lowest cost, he need to we can say the low cost is $30 for drawing 10 caricature. I can say that, or let me see, something is better than that or not. Or you can say that to minimize his cost, Stephen have to draw 10 caricature, or in order to get the lowest cost, Stephen must have to draw 10 caricature. That's what I mean. To get the lower cost, or to minimize the cost. Okay. Okay. And for question B, how many caricatures must be to minimize his cost? Oh, that's what it is. 10. It will be 10. Okay. State the minimum total cost. The minimum total cost will be $30. At least he need to spend $30. That's what it means. Okay. Okay. Graph a function by hand, label the processes, and show the. They want to graph a function, but over here this is 30 and this is it's 10. So I don't think I'm gonna just go ahead and graph it, because we need to graph in paper, and then we need to scale it really well. So I just can go ahead and sketch the graph how it look like. So it's gonna be opened up like this, and find the increasing and decreasing interval. And if you cannot really graph it correctly and perfectly, it's very hard for you to find increasing and decreasing. But whatever, well, based on what we have here, I think I can draw the interval of increasing and decreasing. However, this is not a perfect. It just give you the sketch of what the graph look like. So the increasing will be from whatever here. So we're gonna have 10. Increasing will be 10 to infinity. Positive infinity. This is increasing, and the decreasing will be negative infinity to 10. We never use a bracket for increasing or decreasing. Okay, and it wants us to interpret this interval in term of the context in term of the context. So in the context, I'm sorry, you need to interpret this in the context also. Let me see. Oh, it's nothing now. It just say that we can say that the cost of producing the caricatures decreases until 10, and after this one the cost of production increasing. So that's all I can say over here. So the cost will be decreasing first, and it will be increasing first after 10 draw. Okay. Well, yep. So I think that's all, right? I don't know any other things I should talk about. I try to interpret the first question in a better way, but I don't think there's any other better way. You just maximize and minimum this minimum. So in order to minimum the cost, he need to draw 30 drawing. He need to do 30 drawing. Minimize the cost. Yeah. Because if he draw less than 10 caricature, then just think about it. If it's less than 10, for example 9, right? Then you plug 9 here. 9 is negative 10 is negative 1. Negative 1 is 1 upon 25. So we have $30.25, and the price, you see the price increasing. So if he draw less than 10, the cost is increasing. I don't know why he draw why the cost increasing when he draw less than 10. I'm talking about this in terms of business. I'm sorry, I'm not a business guy, so let me think. So the cost is increasing if we draw less than 10. Really? In terms of business, what does it mean? I mean, if for math, it's totally makes sense, you know. But why he draw less than 10? Then the cost increasing. The cost of what? The cost of hiring the booth and the rental fee. Maybe because when he draw less than 10, he doesn't have enough money to pay for the rental fee and to pay for the park. So that's why he doesn't have enough money, and the cost is increasing. You know, if he draw more than 10, then the cost will be decreasing because it will be minimum. Will be the minimum one. So it means that I think he has enough money to pay for the park. Yeah, I think that's what it means in terms of business and economy. Okay, for the math, it's nothing hard. For the math, we just go ahead and using the formula here. So math is totally logical here, but we try to think about it in terms of business. Okay. But anyway, so that's all for that's the end of section 4.2. Let me see, I can start a little bit of section 4.3 or not. So in this section 4.3, we learn quadratic inequality. It means that we're gonna have a quadratic function, a quadratic equation, but instead of using equal, we can have greater than or less than or greater than equal. and we try to solve, because this is a quadratic inequality, so the solution is not just 1 or 2 anymore, but it's just a bunch of solutions. Let me see, I think I'm gonna just go ahead and start it a little bit. Then in the next video we're gonna talk about that deeper. Okay. So it is section 4.3. Okay, quadratic inequality. Okay. So the method of solving quadratic inequality that we have to graph, or we have to set up the side table. But first we need to take a look what does quadratic inequality look like. What does that mean? So quadratic inequality is it is an inequality, of course, but it's in quadratic form. For example, it's in the form ax squared plus bx plus c could be greater than 0, less than 0, or greater than equal 0, or less than equal 0. So this is all quadratic inequality here. And the solution of quadratic inequality is about a bunch of value. Also, I can say that because it is a bunch of values, so we have to represent that solution using interval notation. Okay. And the method to solve quadratic inequality, we can graph. For example, I want to solve x squared minus 5x minus 14 less than 0, and I have to graph this, and I need to locate two intersection points of the graph and the x-axis. Two intersection points. Let me see, I can in order to get the intersection, we should factor. So this one become x minus 7 and x plus 5 less than 0. So I can see that one of the intersection point x component will be -2 and the other one could be 7. And the vertex will be, what we're gonna do, -b over 2a. So we're gonna have, will be 5 over 2, will be 5 over 2.5. So it's gonna be something like this. Let me see. It's not really a scale, so 2.5 is over here. Okay, so we're gonna have something like this: -14, -14 here. Okay, there you go. Okay, and this is the axis of symmetry, of course. And we have the parabola concave up. Okay, so when I write x squared minus 5x less than minus 14 less than 0, it means that I want to find all the interval that make the function below the x-axis. So this is the x-axis and this is y. So the function below the x-axis, the part of the function below of x-axis is right over here. It's right over here. Right? Because this one below the axis. This is the axis right here, right? And it's below. Okay? It cannot be here because it's above. Okay? This is above. Above, I'm going to use blue. Okay? This is below. Okay? And this is above. This branch is above the x-axis. This branch also above the x-axis. Only this point, this branch below the x-axis. Okay, and we want to find all the interval that make the function below. So what does that be? What could be? It must be from -2 to 7, right? -2 to 7. Okay, and we cannot use bracket because this is less than no equal sign here. So the solution for this will be -2 to 7. What does it mean? It means that between -2 and 7, not including -2 and 7, we have the function that is negative. Okay, so the below the axis it means it's negative. Mean negative. Above mean positive. Okay. So if I just go ahead and change the sign to greater than sign, then we have to pick these two branches, and then at that time the interval notation will be from -infinity to negative to union with positive to union with 7 to positive infinity. Okay, but they wanted less than, so this will be like this. And another way to solve a quadratic inequality is to using the side table. Okay, so this is the side table. This is x and this is fx, and this is -infinity, this is positive infinity. I'm gonna put these two values -2 and 7. Okay, and you see that this number line here, -infinity to positive and -2 to 7, it divide the whole number line into 3 intervals, right? 3 intervals. So I'm gonna just go ahead and pick the point, any point, in order to check if it this is give you 0. Okay. In order to check if this interval is positive or negative. Okay, so I pick a number 8, I plug it in, I know it's positive, and I pick 1 between -2 will give you negative, and this also give you positive. And I see that I'm gonna delete it because that's what I don't need, because it's positive. We want negative, so I'm gonna pick this one only. Okay. So again, your answer will be -7. So there are two methods to solve quadratic inequality, by graphing or by the table. I really prefer the table because I can do it faster. For the graphing, I have to graph it. I need to sketch well, scale it, then I can get into table. But for the table, I just put it on the number line. Okay, and I just pick the value in each interval and see which one give you positive, which one give you negative. Then I pick the one that corresponding to the question, the interval of correspondence to the question. It will be the your solution. Okay. Okay. Anything else? Let's see. Let me see if we can find some application here. Well, something interesting, you know. It's just the number is too big. Every time we talk about application, the number is too big for that 600, 3,000, because quadratic function is most of the application related to money. You know, we don't have small money like this, like $14. So it's very hard to find something with application here. Well, you don't have it. So I mean, let's do another example anyway. I think there's a very good example right here. We have inequality x minus 3 totally squared greater than less than 0. Okay, this is a perfect square. You see that? And if it the square is always positive. We don't have negative. Okay, so what does it mean? How would I write a solution here? Okay, I'm going to write a solution. If x equals 3, it equals 0. But if more than 3 or less than 3, it's always greater than 0. So your answer over here is just what? Your answer here will be x equals 3 only, right? Because you can just go ahead and take square root. You have x minus 3 square less than 0. It means x minus 3 must be less than equal to 0. This is an algebraic way, okay? Then x will be less than 3. Let's see. If x less than 3, let me see. No, we cannot write it. This doesn't make sense, because if x, okay, your x less than 3, for example, like 2 minus 1 is 2 minus 3 is negative. Well, negative 1 square, it still give you positive. See, so this doesn't work. It doesn't make sense. A lot of students will also commit the same mistake right here. So you must be very careful right there. In order to get equal, so your answer is just x equals 3. X equals 3 will satisfy the inequality. That's the only value that satisfies the inequality. So you see that sometimes inequality, the solution is just one value. The solution is just one value. It happened. Okay. It's not always interval notation. Okay. But this is very special case. Most of them must be in interval notation. Yep. Or another example like this. X squared plus 3 less than 0. Okay, you have something with x squared plus 3 less than 0? No way, right? No matter what you find the x value, you plug into that inequality, it cannot be less than 0. It's always positive, and because it's always positive, so we have no solution. It means that we couldn't find any x value that satisfy inequality here. In the last example, we can find a value that satisfies inequality, because this inequality is less than equal. It does not satisfy the less than, but it's also satisfy the equal part. So it actually for 3 work. Okay, but the other one does not satisfy. Yep, so I think that's all for the lecture video today. Basically I finished section 4.3 already. So, and then if you have any questions, just let me know. Okay, sometimes I went going so fast and I missed something, or maybe I'm writing, I might write something wrong, but I don't think so. It's just let me know if you can find any mistake here, careless mistake. If not, in the next video we'll do section 4.4. we learn how to solve a radical equation. This section will be very easy also. Alright, so put your comment if you have a question, and looking forward to the next video in about maybe 10 days. Alright, and I'll see you next time. Bye bye.